Last night at 8 p.m. Eastern Time, NOAA released an updated space weather warning that has aurora hunters on high alert. What the solar observation satellites recorded could bring us one of the most spectacular northern lights shows in weeks. Tonight. Welcome back. Since December 20th, we've been tracking the development of an unusual phenomenon on the Sun, a giant transequatorial coronal hole, a dark region stretching from our star's northern hemisphere deep into the southern. We watched its rotation toward Earth, documented its unusual U-shape, and asked ourselves, how powerful will this solar wind be? On December 21st at 8 p.m., NOAA presented their latest data, and today we're looking at what that means for us. NASA's Solar Dynamics Observatory, a satellite that monitors our sun 24/7, was perfectly positioned to capture this coronal hole, a region several 100,000 kilometers across. That sounds massive, and in cosmic terms, it is. A magnetic superhighway directing fast solar wind straight toward Earth. What the instruments recorded exceeded expectations, a clear signal, not diffuse, but defined. Open magnetic field lines through which solar wind streams into space at 300 to 500 miles per second. NOAA lead forecaster opened the briefing with a clear statement. This solar wind stream will impact Earth, and it will trigger geomagnetic activity. That may sound simple, but after recent weeks of surprises, a G1 storm arriving earlier than predicted, this confirmation matters. The data shows more, speeds around 370 miles per second, not spectacularly fast, but consistent. Shaped by open field lines as the sun rotates, and here's the fascinating part. The KP index, our measure of geomagnetic activity, could reach 5 tonight. That means G1, a minor geomagnetic storm. And that means auroras visible as far south as Seattle, Montana, and northern Michigan. But how does this actually work? This question is more complex than it first appears. The European Space Agency has accomplished something remarkable over recent days. Their solar observation satellites map the structure of this coronal hole. The result, it's not just large, it's exceptionally stable. That sounds like technical details. It is, but the implications are enormous. Coronal holes are cooler, less dense regions in the sun's outer atmosphere. The corona, the magnetic field lines here are open, not closed like elsewhere. Picture it like a highway. While solar wind normally gets slowed by twisted magnetic field lines, here it escapes unimpeded, direct, fast, targeted. And when this solar wind reaches Earth, it slams into our magnetosphere, our invisible shield. Normally, this field deflects charged particles away, but when the solar wind is strong enough and has the right magnetic orientation, a southward component that connects with our northward pointing field, then doors open. Through a process called magnetic reconnection, particles can penetrate our atmosphere. At altitudes between 60 to 250 miles, they collide with oxygen and nitrogen. These atoms get excited, absorb energy, and when they release that energy, light, green light from oxygen, red light at higher altitudes, blue and purple from nitrogen. That's what we call the aurora. What do you think? How far south will the northern lights be visible tonight? Montana? Seattle? Write your prediction in the comments. NOAA didn't just issue warnings. The Ovation Aurora Forecast Map, our most powerful prediction tool, shows the likely extent of the auroral oval. Result: Alaska, definitely. Northern Montana, very likely. Seattle, Edmonton, possible under favorable conditions. But there's a difference. The forecast shows overhead position, directly above you, but auroras can be visible on the horizon, 30-40 degrees up. That expands the visibility zone significantly. Not dramatically down to Texas, but measurably different from quiet nights. This confirms what we suspected. Coronal holes become more frequent after the solar cycle passes its maximum. We're now in that phase. Solar cycle 25 likely peaked in October 2024. Since then, solar flares are decreasing, but coronal holes are becoming more frequent and stable. Another discovery, this coronal hole is recurrent. It rotates with the sun and returns to a geo-effective position about every 27 days. Why? Possibly because it's anchored in a stable magnetic structure. For this coronal hole, that means it could send us another solar wind stream in 27 days. Picture that, every 27 days, an aurora chance like clockwork. Why do we care so much about a hole in the sun's atmosphere? Here's what NOAA isn't saying loudly, but means this is a test. A test for the day when a solar storm becomes truly dangerous. Every day, solar wind flows through our system. Most streams are harmless, predictable, weak. But coronal holes remind us our magnetosphere isn't an impenetrable fortress, it's part of a larger network. Solar winds can compress it, deform it, partially breach it. They carry information, magnetic signatures, insights into processes happening on the sun. NOAA administrators mentioned something else in the briefing. Precise forecasting of coronal holes is a dry run. A dry run for space weather forecasting. If a massive solar storm, CME or superflare, ever heads on collision course with Earth, we need to know its path with extreme precision. This coronal hole isn't a threat, but it's an exercise, and it works. Within 24 hours of first detection, dozens of observatories worldwide monitored the phenomenon. NOAA, ESA, NASA, private observatories shared data in real time. That's not a given. That's years of preparation, protocols, trust between nations. The solar wind stream is hitting us now. Over the next 24 to 48 hours, it will pressure our magnetosphere. Too weak for satellite damage. Too weak for power outages, but strong enough for a light show that could captivate millions. In a few days, the coronal hole will rotate out of geo-effective position. In a few weeks, it could return. In a few months, as solar cycle 25 continues declining, such structures will become even more frequent. Perhaps someone will look up tonight and wonder, how does this light form? Thanks for watching, and don't forget, if you think we'll see spectacular auroras tonight, share your thoughts in the comments. Until next time.